Welcome to Dr. Nakamura's lecture series on Advanced Bridge Engineering. Number B-4.2. Part 4. Steel eye-girder bridge partially filled with concrete. The steel plate girder bridge with eye section is the most common bridge type, which is applied to the span lengths 40 to 60 meters. The negative bending moment at the intermediate supports is largest and critical, and the lower flange and web are very thick, as shown in this example bridge. So, concrete is filled in the area between the flanges and the web. Vertical and horizontal steel bars are arranged on the concrete-filled area. We carried out bending tests for this partially concrete-filled girder. There are 4 test specimens with 3.6 meters long and 900 millimeters high. MS is the steel girder. MC is a partially concrete-filled girder. MCN is also the partially concrete-filled girder, but the steel bars are not welded to the flanges. MCR will be explained later. This shows relations of the applied load and the vertical displacements at the center. MS steel girder is the lowest. MC partially concrete-filled girder has a bending strength twice large of the steel girder. MCN also has large strengths but a little bit smaller than MC. You can understand this partially filled girder is very effective. This shows the final appearance of MS. The upper flange and the web buckled, which decreased bending resistance sharply. This shows the final appearance of MC. Filled concrete crushed and peeled off. The upper flange buckled, but it is small and deformed only outwards. The web did not buckle. This is the final appearance of MS again. Concrete was filled in this buckled steel girder. This is MCR. Then the bending test was conducted. Look at the results of MCR. The bending strength became much larger than the original deformed steel girder due to the effect of filled concrete. So, filled concrete can renovate the deformed section. This partially concrete-filled girder has a wide application for the deteriorated plate girders, such as the buckled web, corrosion, and fatigue cracks. It's very promising. Part 5. Cable-stayed bridge with CFT girder. 2 pipe girders are arranged at the both edges, which is composite with RC slab. Concrete is filled in the pipe girders at the area of A1, A2, and B, which is subjected to axial compression. Filled concrete in A1 and A2 also work as the counterweight to prevent uplift at the end supports. On the other hand, the area C has positive bending moment and no axial compression. Therefore, steel pipe composite with RC works very well. CFT is effective for compression and bending, so it's ideal as a girder of cable-stayed bridge. This illustrates the proposed cable-stayed bridge with 2 CFT girders. This is the illustration of the front view of the cable-stayed bridge with 2 CFT girders. We made a model of this bridge. It is structurally rational and looks nice. This is an alternative solution. This is one cable plane bridge with 3 pipe girders and a steel orthotropic deck. The center pipe is the main pipe girder. This is the illustration of the cable-stayed bridges with 2 and 3 pipe girders. We designed the cable-stayed bridge with pipe girders with a span length of 500 meters. Then wind tunnel tests were conducted for the pipe girder bridge with 3 attack angles, 0 and plus minus 3 degrees. It was found that the critical flutter speed was over 80 meters per second. This bridge has a sufficient aerodynamic stability. The proposed bridge is virtually built in the actual lake of Mount Fuji. My student made this computer graphics. The surrounding mountains and the geography are created from the topographic information. The bridge is viewed from many different angles, just like filmed by a drone. The bridge looks new and beautiful. That's all for this lecture. Thank you and see you next lecture.